Alternating voltage is the voltage which changes a polarity at regular interval of time, and the direction of the resulting alternating current also changes accordingly. So here you can consider that the AC source, so positive and negative terminals are here. In AC source, it produces the alternate current. Alternate current means it has the 2L direction, positive half of the cycle and the negative half of the cycle. So that's called alternate current. So you can see that the alternating voltage waveform, how it is produced. Center point is 0. Then phi 1 turn is positive side, negative sign is also there. So alternating current producing that alternating voltage changes polarity at regular interval of time, and the direction of resulting alternating current is like a sinusoidal wave. So this is a sine wave. It's moving like this. Okay, this is called alternating voltage. Alternating voltage. Depending on the time period, it changes its direction, regular interval of time. That's called alternating current. And positive and negative terminals are there. So current goes in a circuit. So you can consider that a resistance is connected to the AC cycle. So load resistance. Now current is flowing through the circuit. It produces the flow of current. The flow of current is like also it's a sine wave. It varies with the direction depending on the time period. See that positive is one direction and negative in opposite direction. So cyclic shows the flow of conductor and sine wave indicates that positive and negative of the cycle. So it producing the sinusoidal alternating voltage and the alternating current. This is called alternating voltage and the alternating current. Okay. So next we are going to see that mean or average value of is mean or average value of is. So AC current. Now we are going to measure the AC current. So when you are measuring the AC current, it has the positive half of the cycle and negative half of the cycle. So when you are adding these two values, you will get the 0. So 0 means you are not able to measure the alternate current. So now we are using that method to measure the alternate current, mean and the average value. So mean and average value is the two methods of measuring the alternating current, right? So mean value, what is meant by mean value or the average value? So mean or average value of AC of alternating current is defined as the average of all the values of current over a positive half of the cycle or negative half of the cycle. So we can take any one half of the cycle, positive or negative half of the cycle. So alternate current is average of all the values of current over a positive half of the cycle or negative half of the cycle. So that thing we are going to take. So at any instant of time, by using the generator, you know that current produced I is equal to Im sin omega t. I is equal to Im sin omega t. Or we can write sin instead of omega t, we can write theta. So theta is angular displacement, you know that. So omega equal to theta by t or theta equal to omega into t. So we are substituting that value instead of omega t, we put theta, right? So next we are going to calculate that area of positive half of the cycle. So you can take any one half of the cycle. Now we are going to take the positive half of the cycle. So I average equal to area of positive half of the cycle or negative half of the cycle divided by base length of half cycle. So here the picture is shown right here. So we can take only positive half of the cycle or negative half of the cycle. Then base length of the half of the cycle. Base length means this is the base length of negative half of the cycle. 0 to pi or pi to 2 pi. So 0 to pi means it is a base length is pi. Here also pi to 2 pi means the base length is pi. So positive or negative, whatever it is, the base length is same. So now we are going to take the base length. Okay. Then that area of that element is stripped. So we are going to take only the small amount of area. That area I is equal, that small area equal to I into d theta. So when you multiply the current and d theta, you can get that shaded rectangular region. So that is called I into theta. So I into d theta is here. So I is the flow of current. Already we know that I equal to Im sin theta. So substituting that value is here. So we are going to integrating on that side. So integrated that value. sin theta into d theta. Integrated that value will get minus cos theta, upper limit, lower limit, pi 0. So substituting the two values, my minus I am cos pi minus cos 0. So what will happen? So we are substituting the values, finally we get 2 into Im. So 2 into Im. So this is the positive or negative half of the cycle, that area. Then I average equal to that value divided by base length of the half cycle, that is pi. So substituting that pi value, you can get I average equal to minus 0.6371 Im. So here that I average equal to, you can take the positive value for the positive half of the cycle. Then negative value, you can put negative sign. So that is negative half of the cycle. Here that 0.6371, அது எப்படி வந்துச்சு அப்படின்னா, இங்க 2 இருக்கு, 2 divided by pi is here. So pi equal to 3.14. So 3.14, 2 divided by 3.14, you are dividing the two value, you will get that 0.6371. So that is the answer here. Then suppose you are taking that large number of current. So you have to I average equal to sum of all the currents over the half of the cycle divided by number of currents. So how many numbers you are going to take? That numbers. So n, right? So this is the method of calculating the mean or average value of AC, right? So this is the one method. Then next method is the RMS value of AC. RMS value of AC means that is root mean square value of alternating current. Root mean square value of alternating current. So root mean square value of an alternating current is defined as the square root of the mean of the square of all currents over one cycle. So the root mean square value of an alternating current is defined as the square root of the mean of the squares of all the currents over one cycle. So here we are going to calculate the square root of the current. So current I is equal to I for that ordinary positive or negative of the cycle. Now we are going to take the I square. So defined as the square root of mean square of the all currents. So we are going to add all the values in the positive half of the cycle, but that current is the square. So you see here I square is there. I square, that is the peak value of I square current. So this is the positive half of the cycle. So we are going to add all the positive half of the cycle. We are going to take the I square. Again, we are going to use the same method. So I equal to, you know that at any stop time I equal to Im sin omega t. So I is equal to I sin theta. So again, that IRMS root mean square equal to area of any one of the cycle square wave. Square wave, you can take that that way positive half of the cycle divided by base length of one cycle. The base length is the pi, you know that. So area of the element I square d theta. So I is that shadowed region, that red color as usual. So I into the theta. You are multiplying that, you will get this area. So I into I square into d theta. So to get that value, you have to integrate that value. So integral of 0 to pi I square d theta. So instead of I, we are substituting the value of I square m sin square theta d theta. So I square பதிலா the value நம்ம substitute பண்ணிருக்கோம். So integrated that value I square m is a constant. So my remaining value 0 to 2 pi sin square theta d theta. So next thing, so you are integrating that value, you will get I square m integral of 0 to 2 pi. So cos theta, you can write 1 minus cos 2 theta by 2 into d theta. So that value is since I square equal to 1 minus cos 2 theta by 2. That value is substituting that before integrating that. So now you can separate that single integration into double integration. You are multiplying that 1 into d theta and integral value into cos 2 theta by divided by 2. So you can take out the 2 is a common. So you can take out the 2 for a common I square m by 2. So remaining 2 integration 0 to 2 pi d theta minus 0 to 2 pi cos 2 theta into d theta. So you know that d theta, integration of d theta, theta sin 2 theta cos 2 theta is integrated, that you will get sin 2 theta divided by 2. So now you can see substitute that upper limit and the lower limit. So you are substituting that value, sin 4 pi is the sin 4 pi equal to 0 or sin 0 is also 0. So that terms becomes 0. So finally you will get that I square m by 2 into 2 pi. Remaining all the values are become 0. So here I square m, the denominator 2 and the 2 is cancel each other. So I square m into pi is that. So this is the I square m. Now we are going to calculate that IRMS. IRMS to square root of that square of that positive half of the cycle divided by base length. Base length is here 2 pi because we are taking the two half of the cycle. So 2 pi is there. So what will happen? 5 pi cancel each other. So Im by root 2 is there. So 1 by root 2, you are dividing that value 1 by root 2, 1 divided by 1.414 அப்படின்னு போட்டீங்க அப்படின்னா you will get 0.7071 m. So that is the value for that 1 by square root. So IRM is equal to 0.07071 Im. So this we find the symmetrical sinusoidal current. RMS value of current is 70.7% of its peak value. அப்போ ஒரு வேவ் இருந்ததுன்னா அதில் 70.71% of the peak value is current. So this is a measurement of the current. That's why this is another method of measuring the current. Then voltage VRMS equal to, you can write 0.707 Vm. So that is the voltage of the circuit. So first one is the current, next one is the voltage. So these are the two methods of calculating the or measuring